Good evening, everybody. This is Jens. We're running short on time, so take it away.
Okay, thank you. I'm sorry for the delay. I will start quickly so that we can go through this lecture. If you are attended the Congress regularly, then you would have seen this, that there are many talks about anonymizing systems were held here. So, for instance, yesterday we had a talk about Tor, and from Len Sasserman a talk about the Pynchon Gate. And in several previous years, there were talks about Tor by Roger Dingledine. We had talks here about Mixminion, Mixmaster, and I guess also about Chubb and John Doe. And if you follow the development in this section, the research, you may know that there are several other protocols like Tarzan or Morphmix or some other things. But one anonymizing network, which has also users, which has a practical side, was not introduced yet. This is I2P, and I want to introduce you I2P in my following lecture. So the structure is following that I will give you just a short overview. Then we look a bit in detail. We look what functionality there is in I2P, how is our messages sent there, and what ways are there to attack I2P, where are maybe flaws. And at the end, I will show some applications, but you saw that I had to change the laptop, and I don't know if I will go to the whole installation procedure and everything. Maybe I just will tell a little bit in the theory about it. Sorry for that. So just the overview. I2P is obviously an anonymizing network. I just said that. It's the development of the network started in February 2003. It was first called, in the early days, it has several names, and then they called it Invisible Internet Project. And there comes also the name I2P, Invisible Internet Project. And yeah, actually we are at the version 0.6.1.30. And you will read everywhere that this is could not provide real anonymity like you read it in Tor, because the full feature set of is built in the version 1.0. So there are in every new version there come new sorry, there will come new features in the software, and so there on the website you find a roadmap what they plan to build in the software in the next days. Interesting, the I2P network or the software itself is developed by anonymous persons. So if you know a Tor network, there you have the Roger Dingledine, who has made some talks here. There is Nick Matheson and other. Normally, you know these guys, and here the developers of I2P go another way. They stay anonymous, and you only know their nicknames. So I2P is a complete message-based network, and different from Tor, it offers you end-to-end encryption. Maybe when you follow the development in Tor, you will have noticed this year about this attack, or no, it's not real attack, but there was a large news that I guess it was a guy from Sweden. He set up several Tor nodes and sniffed passwords. And I guess 100 passwords he made public. It was some diplomatic login sites or so. And this can't happen with I2P because the messages inside the network are encrypted from Alice to Bob. So there's no exit node who can sniff all traffic. You just see all is encrypted there. So in I2P, the protocol itself is a little bit complex, and I introduced here several terminologies, several words, and I will, in the following, explain some of the terms which are used here. You can read here the router, tunnel, gateway, and so on. So the simplest part is a router in the network. A router is just a normal PC with I2P software installed on it, and that's all. So there's nothing special about it. And the special thing in I2P is the so-called tunnel. Tunnels are unidirectional paths through several routers. So when you start your I2P software, it builds an inbound and an outbound tunnel. So, and if you, for instance, click on a web page, then the request for the web page will go through the outbound tunnel, and at some point the web page answers this request, and this comes back through the inbound tunnel. So that's a little bit different from other protocols you may know. And every router has several inbound and outbound connections, so several inbound and outbound tunnels. And each of the tunnel consists of several routers. So, and what you may know, or what is similar to other protocols, that those tunnels use layered encryption. It's like the ideas from Chom. And I made here a little graphic which shows a router with just one outbound tunnel. And those tunnels are split, or in several parts. The first part is the so-called tunnel gateway. The tunnel gateway is the first router in a tunnel. So if we look back here, the router with the name A there, this is, in that case of the outbound tunnel, the gateway. And if you have an inbound tunnel, which comes back, so which comes from the outside to your computer, this would be the last hop of your tunnel. So the gateway is the node A or the last node, depending if you have an inbound or an outbound tunnel. And the gateway does several things. If it is an outbound tunnel, or I started with an inbound tunnel. So if it is an inbound tunnel, it receives messages from any peers, collects them, and forwards them along the tunnel until it comes to, in that case, to my router, and my router then decrypts all and shows me the message or whatever it does. And in case of an outbound tunnel, it does some pre-processing on the messages, encodes them, and sends them also along the way through the different routers in the tunnel. Another important point is the tunnel endpoint. There are, like tunnel gateways, two different endpoints. In the case of an outbound tunnel, here it would be the node C, the last point of the tunnel. And if you have an inbound tunnel, then it's the other one, the the creator of the tunnel. So, and the specific thing here is that the endpoint of the tunnel is not necessarily the endpoint of the communication. In the further designs, or in the end design of I2P, the endpoint of one tunnel can choose just another tunnel which routes the message along, and the next endpoint then, for instance, sends the message through the receiver of the message. So, but at the moment, the endpoint of the tunnel is the endpoint of the communication. That's the actual point, but in future this will change. And one of the key concepts of the I2P is the network database. So normally your router should know about where to send those messages, should know about the tunnels and so on. And all those informations are stored in the so-called network database, or the short version is NetDB. And the NetDB is just a pair of algorithms which share those network metadata. And main part of it is, or the main algorithm is a distributed hash table. It's called Kademlia. And well, I2P doesn't use the Kademlia itself, but a derived version from it. And the second algorithm is for bootstrapping the network. They use some floodfill peers, and they are by definition always the nearest nodes. And this Kademlia algorithm just measures distances between different nodes. And if you look at normal network measurement distances, you will see that they use they count the number of hops which a message needs, or they count the round trip time, or so on. And Kademlia goes in another way. They set to every router a specific node ID. It's a, I guess, 160 bits long identifier. And when they measure the distance between two hops, they XOR the node IDs. And in the paper of the algorithm, they prove that XORing is a valid distance measure, and so they use it here in I2P2. And coming back to the network database, every router maintains its own network database. So it's not like in Tor that there is a central database, like this. In Tor they call it directory servers. Here, every router maintains its own database. And that's why you will often hear that I2P follows this peer-to-peer approach, and that's really true, that the whole network is really decentralized and there's no central information, so on. So, and the network database itself contains two types of metadata. One is the lease set, and another one is the router info. The following I'll describe shortly what it is. The router info is metadata which is used to contact another router, and it contains several things. First of all, the router's identity. There is a 2048-bit El-Gamal encryption key, plus a 1024-bit DSA signing key, plus a certificate, which is all the router's identity. Then you have a contact address, and this is normally the IP address of the server plus the port where you can reach this